Okay, so what I'm fixing to show you here, I'm only going to show you this once. Again, when we make our triangles in just a second, what I'm fixing to do is not really going to matter. That it works with any triangle, and I'll show you what I'm talking about in just a second. So let's say that it wanted me to rotate 45 degrees, just because it's going to be easy. That's going to put me in the first quadrant here. Okay, well, let's talk a little bit more about those special right triangles. So a 30, 60, 90 and a 45, 45, 90. Every time you have a 45, 45, 90, is the hypotenuse always 2? Or is the hypotenuse always radical 2? No, but it's in some dimensions of this. So think about if I were to take that triangle, keep the angles the same, and I were to enlarge it to make the sides longer, or if I were to shrink it to make the sides smaller. All the sides are going to stay in a perfect proportion with each other. So like, for instance, if I had a 45, 45, 90 whose hypotenuse was 10, okay, and they wanted to know, what are the other side lengths? Well, really what I did was, it used to be a 2, now it's a 10, so I've multiplied it by a multiple of 5. I've stretched it by 5. So what I can do is multiply all the sides by 5. So this is 5 radical 2, and that's 5 radical 2. And it's still a 45, 45, 90. It's just in different dimensions. This is still the same sides. So, again, don't write this down. I just want you to think through this. So if I were to take this, and I was to ask you, what is sine of 45 degrees? Sine of 45 would be the opposite over the hypotenuse, which is 2. Okay, now in this triangle, what if I ask you to find sine of 45 degrees? That would be the opposite, which is 5 radical 2, over the hypotenuse, which is 10. Well, this will reduce. 5 over 10. This becomes a 1, this becomes a 2, and so it's radical 2 over 2. So all 45, 45, 90s have the same ratio of sine, cosine, tangent, no matter what the hypotenuse is. So in actuality, if I were to draw on my unit circle, and I had a 45 degree angle here, really, my hypotenuse is 1, because it's on the unit circle. So what did I do? I took what used to be a hypotenuse of 2, and I've made it 1. So that means I divided everything by 2. So I could do that with my other sides as well. So instead of radical 2 over 2, instead of radical 2, I could write this side as radical 2 over 2. And then I could write this side as radical 2 over 2. But this triangle is really ugly. Do you agree? Having to get all those sides every time? It's much easier to work with this one. So, if I were to still find sine of 45, it's going to be what? It's going to be the opposite, radical 2 over 2, over the hypotenuse, which is 1. When I put it over 1, that's useless. It's still radical 2 over 2. It's still the same ratio as any other 45, 45, 90, even though it's been shrunk. So, when we're fixing to start doing it, like we built all the tools, we went through all of it. The only thing that's different is when I make my triangles, I'm never going to make the hypotenuse 1. Just think about if I shrunk it down, because the ratios stay the same. Does that make sense? We're still in the unit circle, but I don't want to have to go through this process every time of changing my special right triangles that I have memorized to fit into the unit circle. That's crazy that I just erased that 1. Didn't even mean to. Okay, so now we're going to build. We got one more thing I forgot we got to talk about. We got to talk about reference angles. Okay, so we've done some of this already. It was in section 1. So if I told you I want you to rotate 150 degrees. And then I said, what quadrant does that put me in? Remember, I made you draw the triangle. Okay, where's 150 degrees go? It's in the second quadrant, because right here's my initial side, and I rotate 150 degrees, which puts me here, is my terminal side. And I rotate to go here. But now we're going to be using trig functions from this 150 degree rotation. So 150 degrees tells me where to rotate to, what quadrant I go in. But now the reference angle is, well, if I were to make that rotation into a right triangle on the unit circle, what is the reference angle that's formed here? My central angle. The angle that's in the center of my triangle. So let's think about it. If I rotate 150 degrees, then this part here is how much is left to get me to the x-axis. 30. So for 150 degrees, the reference angle is a 30-degree angle. So if I ask you, what's the reference angle of 150? It's 30 degrees. When we make our reference angles, we're always drawing our triangle to make it touch the x-axis. The one mistake people make early on, let me give you another example here. If I ask you to rotate 100 degrees, okay, where does that put us? That puts us in the second quadrant here. A lot of times people try to draw their triangle here and make it touch the y-axis. Okay, that's wrong. All right? You always draw, it's called a perpendicular foot. I'm going to go from wherever I ended to the x-axis. Always to the x-axis. Don't go to the y-axis. So if I were to go down here, then what is my reference angle? If I rotated 100 degrees, then how much more would I have to have rotated to get to the x-axis? 80 more. So here my reference angle would be 80 degrees. Which again is not one of my nice special right triangles, but it could still happen. Right? I could still rotate 100 to get me to a reference angle that's 80 degrees. Okay, let's do another one. So what if I did 240 degree rotation? So if I rotate 240, what quadrant does that put me in? The third quadrant. So right here I am, 240. Oh, I messed up. Puts me here. So now what's my reference angle? So it's what? Okay, so you want to keep rotating to this x-axis. We could, but if I do 120, I won't have a right triangle. All trig is based on is right triangles. So I need to go back to the x-axis as quickly as possible. So here I'm going to go back to this x-axis, because that's going to keep that angle under 90. Technically, yes, but reference angles are always positive. Thank you. Reference angles, always positive. You're right. Because the way I rotated, it would be a negative 60 degree rotation. But in that triangle, we're just going to call it 60.
How do we know it's 60?
Who asked? Call?
No.
Okay, if I've rotated 240 degrees, are you good with that putting me here?
Yeah.
So if I'm backing up here, what is this rotation? If I went just to here.
180.
Yeah. And so I've went 60 degrees more than 180. Right? I went 60 more than 180. So you could just take 240 and subtract 180. We're either going to 180 or we're going to 360 or 0, right? Depending on what quadrant I'm in, where it's going to go to. All right, let's do another one. What if I gave us an angle of negative 30 degrees? And I told you to draw it. Negative 30 degrees is going to put me in the fourth quadrant, right? Because I'm rotating clockwise. And now if I go to the x-axis as quickly as possible, I'm going to go back here. Now what is my reference angle? 30, right? All I've done is rotated 30 degrees in this direction, so to go back, it's still going to be 30. Okay? Any questions about reference angle? How we find them?
So it doesn't matter what you give us, like negative 30, it doesn't matter if that's positive.
Right. I can tell you which way I want you to rotate. So negative tells you to rotate clockwise. Positive means rotate counterclockwise. You have to rotate to that position, then you're going to draw a triangle. Whenever you draw your triangle, the central angle or the reference angle always is positive. The negative just tells you which way to rotate to get to that position. Good. Anything else?
You don't have to go to angle 180 or 360.
Yes. You're always going to the nearest x-axis.
You could go to 90 or 270.
No, because
That's a y.
correct. That's what we talked about. That's the common mistake people will make. People think I can go to 90 or I can go to 270. When you do that triangle, so the way I explain it is I say if I were to go to 90, then your triangle is going to be touching the y-axis, right? Because that's the way I'm rotating. But we're always going back to the x-axis every time. Okay. Anything else? I don't know. I got a good. All right. So we tried to find these reference angles. Have you done all of them yet? Have you done the first one? Okay. So if I were to rotate negative 300 degrees, what quadrant does that put me in? In the first one. So this is a negative 300 degree rotation. And so what is my reference angle or my central angle? 60 degrees. Questions?
Well, so you don't have to draw it, that's just to help you
You don't have to do what?
visualize it?
To draw it? You don't have to draw this big arrow. You need to get in the habit, this is the answer, but you need to get in the habit of knowing what quadrant it draws me in. Because what quadrant I'm in is going to matter with is sign positive or negative in this quadrant? Is cosine positive or negative in this quadrant? Is tangent positive or negative in this quadrant? So you need to know where it puts you. All of them are in that one. You're very good. What about 390? Have we done it? What quadrant is 390 in? The first quadrant? And then what's my reference angle? 30. Because I've went 360 all the way around. And then to get to 390, I have to go another 30. So I have to back up 30 right to get there. Okay? So here's the deal with these two. Everybody has to figure out a way that makes sense to them. Okay? I can tell you how I do it, but I know my brain's weird. And I do stuff in a weird way. Okay? You could take this, you could convert it to degrees. First thing. And then you could just go from there. Right? That's an option. You could, but you also need to know the radian equivalent. That's why I want you to write both. Because I know some of you will just convert this to degrees. You write what it is in degrees and then find the reference angle in degrees, which is fine. But you need to know how to also do it in radians. And same here. For me, again, my brain works strangely. So like if I was doing this one, 5 pi over 6, I know that 5 pi over 6 is really close to 6 pi over 6. And I know 6 pi over 6 is pi. That puts me to here. So if I didn't quite go to 6 pi over 6, but I only went to 5 pi over 6, that tells me I'm going in the second quadrant. Right? I mean, I can do that in my head. That's the way that makes sense to me. And so I know I'm here in the second quadrant. And now, so what's my reference angle? Well, to get to here, that's going to be 6 pi over 6. So that means that's another pi over 6 for my reference angle here. Because I rotated 5 pi over 6, so I had 1 pi over 6 to go. So this reference angle would be pi over 6 or 30 degrees. Right? That's, again, my process. So whenever I explain it, that is how I'll say it. That's not the only way to do it. You just have to come up with something that you can do that makes sense to you. So like on the next one, negative 15 pi over 4. That's almost negative 16 pi over 4. Negative 16 pi over 4 would be negative 4 pi, right? Because 16 over 4 would be 4 pi. So it's almost negative 4 pi, which means I'm going in this direction because it's negative. That would be 2 pi. This would be 4 pi. It's almost negative 4 pi, but it's 1 away. So to be 1 away from negative 4 pi means I'm here. Or, yeah, here. And so I know negative 15 pi over 4 is going to put me in the first quadrant. And if I want it to be negative 4 pi or negative 16 pi over 4, I would need to go another pi over 4 radians. Or 45 degrees. So here are the kind of questions the book asked. So this is example 1 of the book. So basically everything we've taught, we're now fixing to put into practice. So this is the grand finale, so to speak. So the way the book talks about it, they talk about rotating t. They write them all as functions, and they're rotating t. I don't really like that IU theta. It doesn't matter. They're telling you we've rotated pi over 6 radians. And they want you to find all 6 trig functions for a rotation of pi over 6. Now we're going to do all this without a calculator. Okay, so you can't plug it into your calculator and put, well, I know what sine of pi over 6 and cosine of pi over 6. All this is calculatorless. So, let's think through this first one. So first, I have to figure out, well, where is pi over 6 at? Pi over 6 would be in the first quadrant. Right, so I've rotated to here. And so if I've rotated pi over 6, that means my reference angle is also pi over 6. But for us, pi over 6, we have to know is the same as a 30-degree angle. So what I have formed is a 30, 60, 90 special right triangle. Across from the 30 is a value of 1. Across from the 60 is a value of radical 3. Across from the 90 is a value of 2. Because it's one of my 2 special right triangles. Is everybody with me so far? Now, in the first quadrant, if I'm going to find all 6 trig functions, I need to know what's positive and what's negative in the first quadrant. When the first quadrant, all of them are positive. Sine, cosine, tangent are all positive. So I know when I get my ratios, they're going to be positive. So I'm going to be finding sine of pi over 6. I'm going to be finding cosine of pi over 6 and tangent of pi over 6. Okay, so from this central angle, 30, sine is the opposite, 1 over the hypotenuse, 2. So sine of pi over 6 is 1/2. And it's positive again because I'm in the first quadrant. And all of them are positive in the first quadrant. Next, cosine of pi over 6. So from that same angle, cosine, oh, don't sneeze. I'm not going to. Cosine is the adjacent, radical 3, over the hypotenuse, 2. So cosine of pi over 6 would be radical 3 over 2. And positive, because I'm in the first quadrant. Tangent of pi over 6. So from this same angle is the opposite, 1 over the adjacent, radical 3. So here's the kicker part. Tangent of pi over 6 is 1 over radical 3. In pre-cal and in trig, we don't like radicals in the denominator. So we have to rationalize this. Okay, so here's how you get rid of radicals in the denominator. Multiply by whatever the radical is on top and bottom. Okay, that's rationalizing the denominator. So now tangent of pi over 6, instead of saying it's 1 over radical 3, I need to say that that's radical 3 over, and then radical 3 times radical 3 is just 3. So I would say tangent of pi over 6 is radical 3 over 3. Now why do you have to rationalize the denominator? I don't know, because the pre-cal people told us they do. When you get to calculus and beyond, you don't rationalize the denominator anymore. But they make you do it in pre-cal and in trig. So it's a good habit, and it's learning how to do it is good, especially for a multiple choice test, like the ACT. Okay, any questions about these three? How we found them? Now, this didn't say find the 3 trig functions. It said find all 6. So, again, in my head, I know these 3, and I know that these 3 are these ratios. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. For me, when I find the other 3, I just partner them up. I know who each trig function's partner is. So for sine, do y'all remember how I told you to partner them up yesterday? Every trig function has a co as a partner. At least there's one co. So for sine, that has no co in it. So its partner is going to be cosecant. So I could say cosecant of pi over 6 is, it's the reciprocal of sine of pi over 6. So if sine is 1/2, then cosecant would be 2 over 1, which we can write as just 2. So cosine, what's the partner for cosine? So that already has a co in it. It'd be secant, right? Because cosine is the co, so secant would be its partner. And so then secant of pi over 6 would be the reciprocal of cosine. So that would give me 2 over radical 3. Only there's a problem. What's the problem? Can't have a radical in the denominator. So I'm going to have to multiply by radical 3 on top and bottom. That's going to give me 2 radical 3 over 3 for secant of pi over 6. And then the partner to tangent is cotangent. And so cotangent of pi over 6 is going to be the reciprocal of tangent. So here's the good news. If I were to flip my actual answer, what's going to happen? I'm going to put that radical back in the denominator. I'm going to go through that process again. So I'm just going to flip my original. Right? Because the original didn't have a radical in the numerator. So when I flip it, we should be good. So cotangent of pi over 6, that's going to be radical 3 over 1, which we can write as just radical 3. Now just a side note, I'm just going to show you. If you did flip radical 3 over 3, that would give me 3 over radical 3. And then what would you have to do? Rationalize the denominator. So that's going to give me 3 radical 3 over 3. But that reduces. 3 over 3 is 1, which leaves me with just radical 3. So if you do flip the answer here, you can still get the correct answer. You're just making yourself do more work instead of flipping the original. Questions?
When you found the other 3, like cosecant, secant, and cotangent, does the negatives and quadrant still apply to those?
Yes. whatever its partner was, it's going to be the same thing. So if sine is negative, cosecant is negative. They stay the same sign. So for instance, in actuality, in the second quadrant, sine is supposed to be the only thing that's positive. Well, really, it's sine and cosecant are both positive, and the other four will all be negative. So we just reference those big three, and then we know that its reciprocal or its partner has the same sign that it does. Good question. Anything else y'all can think of? Do you think you can do B? Or do you want me to do B? Well, it's telling me to find the 6 trig ratios. So I'm going to be finding sine of 5 pi over 4, cosine of 5 pi over 4, tangent of 5 pi over 4, and then they're buddies. So that would be cosecant of 5 pi over 4, secant of 5 pi over 4, and cotangent of 5 pi over 4. So my final answer is going to be whatever I get on these 6 answers. So, first things first, 5 pi over 4, well, I need to know where does that rotate me to? So how do you want me to explain it? My way, or you want me to convert it to degrees?
It's 30. Yeah, do it in 5 pi over 4.
Okay. So 5 pi over 4, in my head, that's a little bit more than 4 pi over 4, which is just pi. So I know if I rotated to pi, that's 4 pi over 4, and I'm not quite there yet. I have to rotate another pi over 4 to get to be 5 pi over 4. So I know then that's going to put me in the third quadrant. And so if this rotated me to 4 pi over 4, then rotating to here was another pi over 4. And I know pi over 4 is 45 degrees. So I know that my reference angle is 45 degrees. Any questions there? I mean, that's one of the hardest parts. Because, I mean, everybody's got a different method. Everybody doesn't think about it the way I do, and that's fine. You don't have to. Any questions from anybody? So now I know what quadrant I'm in. I know what my reference angle is, so I know what my special right triangle looks like. This is a 45, 45, 90. So I know on a 45, 45, 90, across from the 45 is radical 2. Across from the other 45 is radical 2, and the hypotenuse is 2. Again, there's different times you could do this. I'm going to go ahead and do it right now. I'm in the third quadrant, so I need to know what's positive. Well, all students take calculus. That means tangent is the only one of the big three that's positive. So that tells me that sine is going to be negative, cosine is going to be negative, tangent's positive. Cosecant's going to be negative, secant's going to be negative, cotangent's going to be positive, right? Because it's its reciprocal. Everybody good with that part? Now we do our ratios. So for sine of 5 pi over 4, I'm here at the central angle. Sine is the opposite over the hypotenuse. So that's going to give me radical 2 over 2. Cosine of 5 pi over 4 is going to be the adjacent over the hypotenuse. So it's also going to be radical 2 over 2. Tangent of 45 degrees. That's going to be the opposite, radical 2, over the adjacent, radical 2. So I've got radical 2 over radical 2, which is 1. Next, cosecant of 5 pi over 4. So I know cosecant is the reciprocal of sine. So if I flip sine, that's going to give me 2 over radical 2. And then to rationalize this, I have to multiply by radical 2 on top and bottom. So that's going to be 2 radical 2 over 2. Those 2's are going to cancel, which is going to leave me with just radical 2. So cosecant of 5 pi over 4 is negative radical 2. Now they gave us a gift here. What about this one? When I flip, that's the same fraction. Right? So when I flip it, it's going to be the exact same thing. That's also going to be negative radical 2. And then cotangent means I'm going to write the reciprocal of 1. Well, if I flip 1, I still get 1. So cotangent of 5 pi over 4 is also 1. Questions there?